Okay, so 1.4 was about composition of functions and arithmetic of functions. So really anything that you can do to numbers, you can do to functions. You can add them, you can subtract them, you can multiply them, you can divide them. So if you are asked to do something like this, g plus m of 7, that is the same as saying g of 7 plus m of 7. And then you would just use this chart here. So when t is 7, g of 7 is 7, and m of 7 is 6. I don't know why I wrote 7 again. So 7 plus 6 is 13. And then this would be the same as m of 3 minus g of 3. So go to your chart. When x is 3, or when t is 3, m is 9, and g is 8. So 9 minus 8 is 1. So then this would be the same as g of 1 times m of 1, where g of 1 is 9, and m of 1 is 0. So 9 times 0 is 0. No. Get down. Don't tell me no. You can't be up there. Sorry. And then m divided by g of 9 is the same as m of 9 divided by g of 9, where here's 9, m of 9 is 5, and g of 9 is 3, so then this would be 5 over 3. Okay.
Can you keep that like kind of viewable really quick?
Yeah.
Thank you.
This is all being recorded, right?
Yep. Sure is.
All right. Thank you.
So we're going to do the exact same thing except on a graph. We're going to use the graph to find our outputs. So this first one would be the same as p of 5 plus f of 5. I know you knocked the fan over. So p, that's this graph right here. When x is 5, y is 2. And f, when x is 5, y is 1. So p of 5 plus f of 5 would be 3. So this would be the same as f of 2 minus p of 2. So start on the f graph this time. F of 2 is 5. P of 2 is 0. So 5 minus 0 is 0. So this is the same as p of
5.
3. Whoop, 5, you're right. I knew that. I was checking to make sure you were paying attention. No. No, 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 no. So over on the p graph, when x is 3, y is 5. On the f graph, when f is 3, y is 2. And this time we're multiplying, so 5 times 2 is 10. Yeah, I know, I won't let you climb up on the table. I'm a terrible parent. And then last but not least, f of 0 divided by p of 0. Okay, so f of 0 is 0. P of 0 is 3. And then 0 divided by 3 is 0. Hey, get down.
What was the last one again? Where did you get the 0 and 3?
So they wanted me to plug in 0. And then, so 0 would just be 0 on the x-axis. That's the origin here. And then here, 0 on the x-axis is on 3 on the y. No, we can't climb, baby. Okay. All right. So if you're given a function definition, then you're just going to plug in. So I'm going to need my calculator for this one, which the baby threw. Thank you, Aria. Okay. So then this is going to be g of -8 plus k of -8 So plugging -8 into g, let me make that so that you can actually see it. Okay, would be negative, how if I turn this on? Thank you. -5 times -8 plus 5. So g of -8 is 45. And then k of -8 is 8 times -8 squared, -8 squared, plus 7 times -8 minus 9. 447. So 447 plus 45, 492. So then this would be k of -6 minus g of -6. So k of -6 is going to be 8 times -6 squared plus 7 times -6 minus 9, 237. G of -6, -5 times -6 plus 5 is 35. So 237 minus 35 is going to be 202. So the next one would be g of 0 times k of 0. I don't really need my calculator for this one because -5 times 0 is going to be 0. So g of 0 is 5. K of 0, this first term is going to turn to 0, and this second term is going to turn to 0, so I'm only going to have that minus 9 left. So 5 times -9 is -45. And then k of 3 divided by g of 3. So k of 3 is going to be 8 times 3 squared plus 7 times 3 minus 9, 34. And g of 3 is going to be -5 times 3 plus 5. So -10. And then 84 divided by -10 is going to be -8.4. So you're going to see a lot of questions like those three. It's the same process every time where you're just going to get the y's, and then add, subtract, multiply, or divide the y's, depending on what you're asked. And getting the y, whether that's from a table, a graph, or plugging in, you're still just getting the y. Okay? Now, if you have an open circle, that means composition. So G open circle F of 1 is the same as saying G of F of 1, like that. So the first thing I need to do is I need to find F of 1. Now, F is my table. So when U is 1, F of U is 0. So F of 1 is 0. Now, since I know that F of 1 is 0, I can replace this F of 1 with 0. So now I'm looking for G of 0. G is my graph. So when G is 0, or when U is 0, excuse me, Y is 1. So then this next one is the same as saying Q of F of 3, like that. And again, I always work from the inside out. So F of 3, F is my table. So when U is 3, F of U is 1. So that means that F of 3 is 1. Since I know that F of 3 is 1, that means I can replace this F of 3 with 1. Now, G was my graph again. So G of 1 is 4. Oh, that was Q. I copied it down wrong. Q. Q. So Q is my equation. So to find Q of 1, I'm going to plug 1 in. So that's 5 times 1 over negative 7 times 1 squared minus 5. 5 over negative 12. Negative 5/12. Okay. All right. Thank you.
Wait, so we didn't plug the G of F in to that equation because Q and U weren't in it?
Because
right?
all we used was Q and F.
But for the one above it, since it's G of F, that's why we just got 1. We didn't bother plugging that into the 5U over negative 7U squared because
Exactly. Because this one doesn't have a Q anywhere, so I didn't use Q. This one doesn't
Okay.
have a G anywhere, so I'm not going to use G. So this one is only going to use F and G again.
Which is the graph, right?
It's the, so F is the table, because it says F, and G is the graph, because that says G.
Okay.
So this time I want to do F of G of 3. Now I still have to work from the inside out. So G of 3 is what I need to do first. G was my graph. So at 3, the Y value is 2. And now that I know that G of 3 is 2, I can take this G of 3 and replace it with a 2. And then F of 2 is my table. F is my table. So when U is 2, F of U is 5. And then last but not least, q of g of 1. So we start on the inside, g of 1. When u is 1, g of u is 4. So now that I know that g of 1 is 4, I can replace this g of 1 with a 4. And I need q of 4. So 5 times 4 over negative 7 times 4 squared minus 5. So 5 times 4 is 20. And then negative 7 times 4 squared minus 5 is negative 117. I'm like 98% sure that that's not going to reduce. But I'm going to do math enter enter anyway just to check, because remember, math enter enter will reduce a fraction. It does not reduce. So negative 20 over 117. And so then the last piece that is a little different is finding the composition of a function. So this is asking me for k of h of t. When they don't give you a number, you're still going to plug in. Only here I don't have a number to plug in. So instead I'm going to plug in h of t. H of t is 3t squared plus 2t. So a quick reminder that if this had been k of 5, you would have said 3 times 5 plus 5, right? Well, when it's k of an expression, you still do the same thing. We're still going to take this t and we're going to replace it with the thing inside this parentheses. So that becomes 3 times, and instead of t, 3t squared plus 2t, and then still plus 5 at the end. Now, more will sometimes want the answer like this, but sometimes they'll want it simplified. So I would put that in, and if it doesn't work, then I would distribute and simplify. So 9t squared plus 6t plus 5. But one of these two will be what it's looking for. And a little hint that if it says preview like this, then it's looking for something with a variable. So then m of h of 2, we start by finding h of 2, which is 3 times 2 squared plus 2 times 2. So 4, 12, 4, so that's 16. So since h of 2 is 16, then this becomes m of 16. So then we're going to plug 16 into m. So that's going to be the square root of 3 times 16 plus 3. 3 times 16 is 48, 49, 50, 51. And then h of k of 1. First we do k of 1. 3 times 1 plus 5, so that's 8. And then once I know k of 1 is 8, then I replace this k of 1 with an 8. And so then h of 8 is 3 times 8 squared plus 2 times 8. I feel like doing 3 times 64 in my head, so 3 times 8 squared plus 2 times 8. 2. So that's arithmetic with functions and composition of functions. The other video that you should have watched was on sorry, my daughter's banging on the door now. Was on transformations. Thank you. That really probably could have waited, but okay. Thanks. Sorry. Oh, a birthday card. My husband just came in and dropped a pile of mail on me.
Is it today? It's tomorrow, right?
Tomorrow, yeah, but my dad mailed me my birthday card from New York.
Oh, happy birthday. Happy birthday.
Stamps are here. Thank you.
We're a day apart, birthday-wise.
Yeah, when is yours on Friday or is it today?
Mine's on Saturday.
Oh, Saturday. Sorry, mine's on Friday. Yeah.
Happy
I knew that.
birthday.
Thank you. I'm getting really, really old. I feel it in every move that I make these days.
The joys.
Okay, so transformations has a certain set of rules. I should have pulled them up beforehand, but if you just Google transformation rules, you'll find a box that's like f of h plus k, f of x plus h minus k, and then there'll be an a here and a b here. And then you can find something that explains to you what each letter does, a, b, h, and k. And then that way you can have like one. If I find one, which I'll look after we're done, I'll put a link up. I'll like put a link up as an announcement. That way you can have it, because it's nice to have like just one chart that describes all these rules. But H on the inside, I put my signs are backwards. Oops. H on the inside is horizontal movement, where a minus moves right and a plus moves left. This B on the inside is a horizontal compression or stretch. This K on the outside is a vertical shift, up or down, plus is up and minus is down. And then the A on the outside is a vertical compression or stretch. Again, if you watched Andy's video, he explained all of that to you, but I just wanted to remind you. So here, what we want to know is if this was my original and this is my transformed function, what happened? So all of the y's are the same, which means that there was no compression or stretch, there was no vertical shift. But if we look at my h's, my x values, see how all of my x values are off by 1? So if I go from -2 to -3, I have shifted to the left one. If I go from -1 to -2, I have shifted to the left one. Does that make sense? So a shift left 1 is a +1 inside the parentheses. Inside the parentheses, it does the opposite of what you would expect, and outside the parentheses, it does exactly what you would expect. So that's how I always remembered it. It was, because it was a shift left 1, you would think that it was a -1, but it's not. Because really you need to think about what do I do to this to get back here, and to this you would have to add 1. Okay, so now here if we're comparing F to H, this time all of my X's are the same, but my Y's have all shifted down 1, from 4 to 3, from -4 to 5, from 2 to 1. So a shift down 1 would be f of x minus 1 with the minus 1 on the outside. So horizontal change is inside the parentheses, vertical change is outside the parentheses. Okay? All right. So here we want to know, what does this do? So I pulled down the box so that you can see what your options are. So this plus 6 on the outside is a vertical change. Vertical changes affect the y, and it's a plus 6, so it adds 6 to all of the y values. And this next question was asking what happens to the graph. The graph would shift up 6 units. Okay. Tried to get like a random grouping of the types of questions you would see, because I feel like sometimes in more it's not even about the actual question being asked, it's more about how they're asking it. So here, if I have f of x plus 4, inside the parentheses is a horizontal change. So inside, because it's inside, it's a horizontal change. That means that it affects the inputs. So here we would say the plus 4 affects the inputs. So the graph would shift horizontally. And then if you have the plus 4 on the outside, that affects the outputs and shifts it vertically. So again, inside the parentheses is horizontal, outside the parentheses is vertical. Happening inside the parentheses, it affects the x's. If it happens on the outside of the parentheses, it affects the y's. Okay. So here, if we have this function, the 5 on the outside, see how this is not on the inside with the parentheses? That means it would multiply my y values by 5. Now I say multiply this time because it is being multiplied by the f. So if you are multiplied, then you multiply. See the 17? The 17 would add y, add 17 to the y values. And now on the inside of the parentheses, we're going to be affecting the x values, and you're going to do the opposite of what you think. So if this is an x plus 10, then you subtract 10. So again, inside the parentheses, the rules are the opposite. If you have a plus 10, you subtract. If you're multiplying the x, you actually divide the x's by that number. And so now, having said that, let's look at this question, which is, I felt super weird. So we do the opposite of what you expect to the x. So here, it looks like you would multiply it by this and then subtract by this, but no, we do the opposite of that. And we do it in the opposite order. So instead of multiplying and then subtracting, we're going to add. So we take the 4 and we add the 6.6. And then instead of multiplying the negative 7.6, we divide by it. So my new x value is this. Rounded to 2 decimal places makes it negative 1.39. Now, the things on the outside, those affect the y value, and they affect the y value exactly as you would expect. So this negative 7.7 gets multiplied by the 2, and then you add the 11.1. And the order is also the same as you would expect when you're on the outside. So you multiply and then you add. So negative 4.3. Okay. Felt like his video didn't really explain how to do these super well, so I wanted to make sure that I did one of those. Okay, but then last but not least, if you have g of x, and it is x squared shifting up 56 and 59 to the right, then it becomes x, and then the right shift is inside the parentheses. And because it shifts to the right, it's subtracting. So x minus 59 squared. That's my right shift by 59. And then up 56 units would be a plus 56 on the other side. And so we're probably going to want you to do it that way. But that's how you would write your new function. So that was what I had for you.
Can you repeat what you just said?
That was what I had for you.
No, all the way from the beginning. Just kidding. No, but from this last one, the f of x equals x squared,
So because it says 59 units to the right, that 59 goes inside parentheses, and a right shift means it gets subtracted. 56 units up means it goes on the outside of the parentheses, and it's a plus because it's up.
Okay.